Hey everybody, today we're going to be talking through discrete growth. In plain English, we'll be setting up and thinking through problems with discrete exponential change. Sometimes you have numbers or variables that increase by a percent. Maybe you have a neighbor that grumbles, rent keeps going up by 5% every year in this neighborhood. We're going to figure out what happens to his rent. Now, for this instance, let's presume our friendly neighbor was renting a house for $805 a month. We'll find out what his rent will be in the contract he signs 6 years from now. Now, on June 1st, he signed a contract to live in the house for a year, paying $805. However, he wants to live there again, so at the end of the year, he has to sign a new contract. So on June 1st of 2016, he signs a new contract. Unfortunately for him, the owners of the house increase his rent by 5% as part of that deal. Okay? 1 year later, on June 1st of 2017, he'll sign a new contract for even more money. This is called discrete change. Discrete change happens when things go in steps or chunks. You pay the same price for an entire year, then it jumps all at once, right? We're going to make a table to solve this problem. Remember, our neighbor rents a house for $805 a month. Since it's our first year, we're setting up the rent, we're not increasing it. There is no last year's rent, there is no multiplier. Now, rent has gone up 5% each year. That means that we're paying 105% of our old rent, right? That's 5% more than 100%. When this is turned into a decimal, that's 1.05. Every year our rent will go up by the same amount. We're going to be lazy. We're going to fill in the rest of our table with that same multiplier. Boom. Okay, so it's time to move on to year 2. When we do, last year's rent was our first year's rent, which was the $805. So we're going to multiply that by 105%, or 1.05. So 805 times 1.05 is 845.25. We're going to put that in our table as this year's rent. Our rent for year 2, 845.25. For year 3, last year's rent was this year's rent, which is 845.25. Our landlords are raising our rent 5% again, which means we're paying 105% of our old rent. So 1.05 times our old rent of 845.25. That gives us 887.51. This pattern is going to continue over and over again. For year 4, our rent from last year was that 887.51. We're going to multiply it by 105%, or 1.05 in decimal form. 887.51 times 1.05 is 931.89. So that's going to go in this year's rent for year 4. In year 5, it's going to be last year's rent. We're going to multiply that 931.89 times 105%, or 1.05, and we're going to get 978.42. This year's rent is 978.42. For year 6, the previous year's rent was, bring it down, 978.42, and that multiplied by our 105%, or 1.05, is $1,027.41. That's going to be your year 6's rent. In year 7, $1,027.41 was year 6's rent. We're going to multiply that by 105%, or 1.05, and we're going to find that after 6 years of rent increases, our neighbor is paying $1,078.78 instead of $805. Now, for 6 years of rate increases, what we did was we paid $805 times 1.05 for year 2, times 1.05 for year 3, times 1.05 for year 4, times 1.05 for year 5, times 1.05 for year 6, and times 1.05 for year 7. For every year that we go past the first year, we're multiplying times 1.05 again. And we can make a function for this, as we're seeing that we're doing the same pattern. Our function is, our rent is equal to 805 times 1.05 raised to whatever year we're going to, right? Because we're multiplying again and again, and repeated multiplication is the same as raising to an exponent. Now we can actually generalize this function to all exponential, discrete exponential growth. And we can do that by saying, okay, we are searching for our population. And that population P is equal to P sub 0 times 1 plus R times T. Now, what those letters mean is P is our final population value or cost. Now we write it as P because this is normally used for population, like population growth in people moving to an area, or bugs multiplying, or bacteria on a spread plate, but it can be used for anything that follows an exponential function. So it's our final population value or cost. P sub 0 is our starting amount. That normally means at time 0. That means when we begin, right? So P sub 0 is our starting amount. R is our rate of change. For us, it was 5% or 0.05. So 1 plus 0.05 is that 1.05 that we found ourselves using, okay? And last, T is the time. Now, when we talk about this formula, that R rate of change, that can be positive or negative. If you have a positive rate of change, then we're increasing our population. If you have a negative rate of change, maybe an area, lots of people are leaving an area, maybe a factory closed and the areas, people are moving to other places with more jobs, that would be a negative rate of change. So instead of saying 1 plus 0.10 for 10%, it might be 1 plus negative 0.10, and you get 0.9 raised to the T. Okay, that works very well, and it works just the same as increasing our rate. Remember, this only works for discrete changes or situations where we jump in price, cost, or population.